We're going to look at binomial distribution. So binomial distribution runs off us doing finding combinations. So if you remember, combinations is this for the formula. Now it's really important that you know how to work this out by hand, because occasionally it will pop up on Year 12 exams. So if you're not sure, make sure you go through. I'm sure your exercises will have a little bit of practice, or if you look online, there will be some worksheets that you can use, but make sure you know how to do that by hand. Now, in terms of binomial, remember it's about success or not success, and if you want a certain number of successes, for example, if you're flipping coins and you're saying how many heads you want, then there'll be a binomial. Let's say you wanted, out of 8 tosses, you want 5 tails, so you do 8 tosses and 5 tails like that. Then if you read the next line here, that's where you would substitute all the stuff in there. Now, because some mechanically intensive, a lot of times these will be CAS questions. However, I should probably mention, like I said, you might be find stuff by hand. However, I'll be going through the rest of this video using the Casio CAS. So if you do use the other CAS, I would probably suggest you practice it as well, because the functions are quite similar. The other thing I should mention, have a look at the mean, which is n times the probability of success, because you have a certain amount of successes. And then the other one is the variance and standard deviation. Notice the formulas are very slightly different to the Bernoulli trials. Alright, so here's a little example. It is known that 52% of the population participates in sport on a regular basis. 5 random individuals are interviewed and asked whether they participate in sport on a regular basis. Let X be the number of people who regularly participate in sport. So A, construct a probability distribution table for X. Now, what you have to think about is how many will potentially be doing sport. So you can have 0, so none of them. 1, 2, 3, 4, 5. So here's X. Oh, I might make it a bit more fancy. Oops, this one, X. So like I said, 0, 1, 2, 3, 4, 5. And then we want the probability of X equals to X. Oh, that doesn't look nice, does it? Well, anyway, maybe if we just do this, I'll fix it. Looks good enough. Okay, now for each of the probabilities, we can figure out how many are correct by using the distribution function. So if you go on main, we'll clear that. Interactive, distribution. Now, there's 2 types, continuous and discrete. Binomial, because we just want specific values of it, not a set of values. We want discrete. So there's binomial, PDF, and CDF. PDF is for specific values, so if you just want one person, you'd use PDF. If you want multiple, say like 1 to 3 people, then you'd use CDF. Anyway, so we want PDF. This first one, if you read the bottom, specified trials, so how many people we have in this case, which is 5. Sorry, how many successes you want, which is 0 for the first one. Number of trials, so how many trials you're doing, so out of how many people for this one, which is 5. The last one is probability of success. It says 52%, so put in 0.52. Once you put it in, you'll be given the value, so 0.0255. Then the next one, we'll do the same thing. Now, if you did do action instead of interactive, it'll pop up like this, but you won't know where to put the different spots in. So I'd suggest interactive. 0.1380. And then you just repeat the process. Oops. So for 2, 0.2990. Now, you might then ask, why am I not using the other function as in combinations? Well, you can see this is a lot quicker. 0.3240, and then 4, 0.1755, and the last one, 0.0380. Okay, so I'm gonna just change this over here a little. B, find the probability that three people or less play sport. So if you want probability of, we want 3 or less, that means we need to add the probability of 3 to 1 and 0 because they're 3 or less people. Alternatively, you can do 1 minus the rest, which is 4 or 5 people playing sport. It's entirely up to you. So probability of x equals to 3 plus probability of x equals to 2 plus probability of x equals to 1 plus probability of x equals to 0. Now, you could do this by hand, but remember what I was just telling you about the CAS. If you go interactive, I'll clear this first. If you go interactive, distribution, discrete, and then if you go CDF, it means continuous, right? So we can just set 2 limits. It starts from 0 and goes up to 3. Because continuous just counts up all of them for you in one go. We have a number of trials, which is 5, because we have 5 people, and then probability of success was 0.52. So 0.7865. Okay, C. I'll scroll this down a little. Find the probability that at least one person plays sport, given that no more than 3 people play sport. So let's look at how this works. We have probability that at least one person plays sport, given that no more than 3 people play sport. So if you remember, we actually had to work this out in year 11. So remember, probability of A given B is a probability of the intersection of A and B, so the first one and the third one. So if you want greater than 1 but less than 3, given that no more than 3. 3 is still no more than 3. Okay. So we want, if it's greater than 1 but less than 3, must be between 1 and 3. So 1 less than equal to x less than equals to 3 over the probability of x less than or equal to 3. Alright, so we want probability between 1 and 3. So we can just drag the last one down. We'll change the numbers. So the bottom limit is now 1, going up to 3 out of 5 trials. So that's 0.7610. over, and we want specifically the probability of x less than or equal to 3, which is the same as the one before, so 0.7865. And I believe here is the greatest. Nope, thought that works. Put in your CAS, so 0.9676. Alright, B. Find the probability that the first person interviewed plays sport, but the next two do not. Now, here's an interesting one. You might be tempted to use the binomial distribution for this, but you can't. The reason for that is, if you use a binomial distribution to find this one, it doesn't specifically say for that particular person whether or not they're doing sport. When you use a binomial distribution, it talks about overall who is doing sport. So what you have to do is you have to find probability of success for the first person. So we want the first person to have success, which is 0.52. And then you want the next two to not have it. So 0.52 times probability of not success, which is 1 minus 0.52 times 1 minus 0.52. Now it doesn't say anything about the rest of them, so the rest of them don't matter. So we can actually leave those out. Now because it gives you a very specific order as to how you have to find it, you have to actually use this particular way of multiplying it. If you weren't given an order, if it just says one person plays sports but the other two do not, all you literally have to do is to say at least one person plays sport, but no more than 3. But because this one specifically tells you that you have to find it so that it's the conditions right there, you have to find it in this particular order, which then gives you 0.1198. Alright, a test consists of 20 multiple choice questions, each with 5 alternatives for the answer. So you have 5 different options. The student has not studied for the test, so she chooses answers at random. Let x be the discrete random variable that describes the number of correct answers. So first things first, when you read this first part, because it tells you that there are 5 alternatives for answers, your probability of success must be 2, or 1 over 5. Alright, find the expected number of correct questions answered. So we want to know expected number of success, I guess. I'll just say the mean, might be. It probably makes sense. The E of x equals to NP, if you recall. So we have 20 trials, so we have 20 times probability of success, which is 0.2. That means we will have 4 correct answers. What happened there? What happened there? Okay, there we go. I should have just done that. Hang on. Sorry. There we go. Okay, part 2. Find the standard deviation of the correct number of questions answered. Correct to 4 decimal places. Alright. So our sigma squared of variation is, let's see, oops, nope, not capitalized. So sigma squared is NP 1 minus P. So that means if we want just sigma, that will be the square root of all of that. So NP 1 minus P, like so. So then all we need to do is find that. So we have that one. If we put this in a set of simultaneous equations, we can solve it. So in the interest of saving time, I put in the CAS. This then tells us a number of trials and stuff, but obviously we need probability of success normally in decimals. You can leave it as fractions if you're working it out by hand, which is preferred. However, usually it will tell you whether or not it's in, well, given the way the question's set up, it will usually be in decimals. Anyway, so n is equal to 15. I'll just leave that out completely. So then n is equal to 15, and then we have p equals to 0.56. And this is simultaneous